Hello, welcome back to Graphext and welcome to the cross-filter section in which we're going to talk about all these little charts we have in here in the user interface. The cross-filters are essentially a visual representation of each one of the variables you have present in your data. As you can see, depending on the type of the variable, the cross-filter will represent it in a different way. For example, numeric and date values will be represented as a histogram spanning top to bottom to top. Whereas categorical values will be represented as a horizontal histogram, whereas text will be represented as some form of word cloud in which the most important terms are being presented to you. So this way, at just a glance, you can have quick information about what each variable means and what the distribution looks like. All these filters are actually interactive, as you probably may know already, and basically selecting in here will make a whole selection on the data set. For example, in this case, we've selected all the people in the Titanic dataset. Their age is between the 29 to 51 range, basically. And we can move this, we can extend this and whatnot. And as you can see, this makes a selection immediately, which makes for every other cross-filter to change behavior. So if you move this cross-filter in here, you'll see that, for example, this P class category will also change based on that. So what's going on is we have two concepts, the background and the foreground. We call background to the whole dataset with no selection and no filter and just the original dataset. And we call foreground to that particular selection that you've made right now. For example, in this case, this age range of 32 to 65. So all the other cross filters now develop these background and foreground and show you how the distribution differs from the original dataset to the selection you've made. For example, if we have here this age range, we can see there are many more people from the first P class than from the third. Whereas originally there were many less people from the original 1 class than the third class, because when you see the gray bar, the background is being shown there so you can compare the two and you can get a sense of what the difference looks like in this particular section of your data. You can stack up all these filters, of course. You can just select this age range with all the male and just the first class, and that will leave you with just 82 rows, but that may be important to you in the case that you want to see specifically what all these people are about, or how they behave, or what the survived rate is, or something like that. Then, as you may have noticed, when selecting something, the significant variable section lights up and shows us some information. So if we click here, we can get a sense of what is going on. There's two components, the little bars and the numbers. The number just indicates how many variables lie in each category in each relevance level. And then the relevance level just means how relevant these variables that you see here are with respect to the selections you've made. So when selecting this age range, Graphext tells us that the P class and the fair columns are somewhat relevant. So for example, we can hover here and there's a relevant of 27%, and in this case it's 20%. But for example, we can see here that the age is very, very correlated, of course, because we're selecting the age. Graphext evaluates everything, and nevertheless, because you see the circle here, you can maybe just skip this. This would be level 5 of relevance, 4, 3, 2, and 1. And then you can see that there are two columns in here and two columns in here. And for example, if we move this, we'll see that this, for example, now changed from 1 here to 3 here. So this tells us immediately how much relevant information may be hiding in other variables and how these variables react to the selections you've made. As a last note, I want to bring to your attention the fact that you can make custom queries. So as we can see here, if we select any arbitrary range, there's a message here that says query applied. You can click this and this will show this prompt, and you can see that this notation, right, is greater than 27 point some decimals and less than or equal to 54 point some decimals. What we're doing here is basically just taking two subsets of the data and joining them together. So we're taking everything that is over or equal 27 point something, and we get all the distribution, and then everything that is under 54 point something and all the distribution. And then we're joining the two with the and word. So basically we're taking everything that is both in the upper range of 27 and the lower range from 24. which effectively just takes a range. But we could, for example, invert this range. Say that you want everything that is on the sides, but not on the center of this. So to do that, we could just say less than 27, greater than 54, and instead of and, there will be no number which is both less than 27 and greater than 54. We need to be an or, like it's either less than 27 or greater than 54. In this case, we can just select apply and see now everything is selected but the center. Though very specific, this can come useful in some situations. I can think of an IQ test for a lot of people, and you want to see what the very low IQ and the very high IQ people have in common, because usually people with mental health problems usually are quite similar in that regard, even though they are probably very smart or not very smart compared to the actual normal distribution of the IQ. We want to be this small presentation of the cross filters. Please explore, ask questions at support at graphext.com or myself, Jesus at graphext.com. And please reach out, have fun analyzing, and see you in the next one.